Hello and welcome to this new video. In this video, we will study the concept of subgroup and the concept and some examples of a subgroup. Okay, we start with the definition of subgroup. A subgroup is defined as if a subset H of a group G is itself a group under the same operation as of G, we say that H is a subgroup of group G. Okay. Now we will see some notations. Note that we use the notation H is subgroup of G. This notation, which is usually the notation of less than or equal to, but because H and G both are sets, so this notation will show that H is subgroup of G to mean that H is a subgroup of G. Okay. If we want to indicate that H is a subgroup of G, but H is not equal to G itself, we write H is proper subgroup of G if H is subgroup of G and H is not equal to G, then we say that such subgroup is called a proper subgroup of G. Clearly, the set which is consists only of identity element is subgroup and is called the trivial subgroup of any group G. This set, which is only a singleton set E, satisfies all the axioms of group. So it is the subgroup of G. So uh, a subgroup that is not this trivial subgroup E is called a non non-trivial subgroup. Okay, another note that if G is a group, then clearly the singleton set E and G itself, these both are always subgroups of G. Okay. So we will move further with some examples. We know that the set of real numbers is group under addition. Clearly, the set of integer is subset of R, and we know that Q itself is group under addition because the binary operation of this group and this group is same and Q is subset of R. This means Q is subgroup of R because we already know that this notation is notation of subgroup. Also, this set of integer is subset of R, and also this set of integer is group under addition, which is same binary operation as of R. So it is clear that the set of rational numbers and the set of integers both are subgroups of set of real numbers under addition. Okay. And these both are non-trivial subgroups because these both are not equal to the identity group, or also they are not equal to the set real number itself. Okay. Another remark. Zn, which is group under addition, modulo n is not a subgroup of set of integers under addition because addition modulo n is not the same operation of z, which is classical addition or normal addition. Okay, we study some more examples. We know that set of integer under addition is a group, and 2z, which is set of all even integers up to so on, is subset of z, and 2z is group under addition. It is easy to verify all axioms of group for 2z. Okay, but if we consider another set, say A, which is the set of all odd integers, is not a subgroup of Z, although the binary operation is addition in both of the sets Z and A, but A is not closed under addition as 3 and 7 both belongs to A, but 3 plus 7, which is actually equal to 10, does not belongs to A. So A is not the subgroup of Z. So here it is end of the lecture, and if this lecture is interesting and understandable, then please like the video and subscribe the channel. See you next time.